So today I'm going to talk a little bit about how one breathes. Okay, people think that we suck air in and we suck air out. And there is no such thing as sucking. Okay? You know, vacuum cleaner does not suck dirt up. People don't get sucked out of the spaceship if there's a breach. You don't suck water up a straw. None of that happens. So what's really happening, okay? What is really going on here? Well, you've got your lungs, okay? And when you're in a state of rest, all right, this is just a state of rest here, okay? We're just pausing in a state of rest. The air particles, you know, we're neither inhaling or exhaling. The air particles outside are about at the same concentration as the air particles inside your lungs. Okay? And what this means is the pressure of the lungs is equal to the pressure outside. All right? Now, what do we mean by pressure? Well, pressure can be described as an equation of pressure equals force over area. Okay? And for instance, if we look out here in this room, there are millions and millions of air particles zooming around, banging into each other, and banging into me, exerting a force on me. We're at about 1 atmospheric pressure here at sea level, and you know, and that can change. If I go to Venus, where there's a lot more particles, okay, it's much denser. The force, the number of particles that are going to be hitting me is much greater, so I'd experience a much greater pressure there. All right? Because the more particles you have, that means the more they're going to be hitting into you, exerting a force over a certain area. All right? So this is what pressure means. This is why you know instinctively, okay, my tire's getting flat, so the pressure's low. So what do I have to do? I have to add more particles, because that means there'll be more particles hitting into the sides of the tire, inflating the tire. So here we have the pressure is the same. These guys are banging into the sides of the walls of the lung, exerting a pressure which is the same pressure that these guys exert as they're banging around, because they're equally spaced apart. Now, when you inhale, what does your body do? Your body has two muscles that change the volume of your lungs, and one of them is the diaphragm, and the other one are the little muscles along your rib cage called the intercostal muscles. So these guys change the volume, and let me just make your lungs a little bit bigger here. There we go. We can make them a little bit bigger. There we go. Okay, so they change the volume of your lungs, making them bigger. So here's those. We had 3 of these air particles in each one, nitrogen, oxygen, whatever it is, carbon dioxide. And here they are, and you can see they're spread out more. Okay, these guys are close together. And so the pressure in the lungs is less than the pressure outside, okay, in this situation. And air particles are like us. They like a certain comfort distance between each other. All right, so if you look at these chairs here, they're kind of spaced out where there's, you know, room to move around. It's comfortable, okay, and that's what we like. If you look over here, would I ever find students in desks like this? No, I wouldn't. Okay, I would not find any students in desks like this. I would find them over there like that, but not like that, because they don't want to be squished together. Neither do these want to be squished together. So these guys on the outside, they say, oh, look at all that room inside. Let's move in. Okay? You don't do anything other than change your lung volume, though. They're the ones moving. Then when you exhale, your diaphragm muscle relaxes. Here we go. We're exhaling. And all those air particles, all the nitrogen, oxygen, and carbon dioxide that moved in, are are now all squishied together. And outside it's staying the same as usual. Same number, same spacing, same pressure. So now we've changed it, and we've created a situation where the pressure of the lungs now, all right, is greater than the pressure outside, okay? And when that happens, the air particles then want to zoom out on their own accord. So they move out. You do not push them out. They move out on their own. So this is what happens in respiration. Gases like to move from high concentration to low concentration, and they do that on their own. Okay, and that's how you breathe. Not by sucking and pushing, but by just changing the volume of your lungs.